this. It's going to be wavy and clear. I just took pictures with my phone and uploaded them. So they won't be as clear as I'd hoped, but you're just following along in your book or on the paper right now. Okay. We're doing radicals. This is the first bit. So most common one that everybody sees is the square root. Okay. Can you square root a negative? No, you cannot square root a negative. Okay. So square root of -4 is can't do. Nope. I mean, look, if you go on in math, you will be taught that you can do it. There are things called imaginary numbers. We don't talk about them in this class or in high school, but for us, you cannot square root a negative. If we square root 16, so we're doing root 16, you always get two answers when you square root something. All right? Positive and negative. So the answer would be plus or minus 4, because -4 times -4 is 16, positive 4 times positive 4 is 16. Okay. We all good with that? Okay. Cube roots. That's when you got this little 3 hanging out here. You can cube root a negative. Okay. So if I say the cube root of -27 is -3, because -3 times -3 times -3. 3 times 3 times 3 is 27. A negative times a negative is a positive, times a negative again gives you a negative. So when you're doing a root that is an odd number, so the 5th root, the 3rd root, the 7th root, things like that, you can do a negative. Okay? If it's an even one, like this, there's a 2 up there, or the 4th root, we're going to see that later on, 6th root, you cannot do a negative. People heard that before? Nope. Okay, so if I said, what is the 10th root of -4? What would you answer? Can't do it. You can just literally write nope if you really want to. All right, but if I said the 11th root of -4, you can do it. Okay, that is possible. All right, so let's just look at these ones here. Without a calculator, what's the square root of 49? 7. Now, this is where things are going to get slightly technical. We're not going to worry too much about it in this class. If the root is already there, it's only the positive root. Okay? If you're going to see, like, later on, we're going to solve equations. You know what? I'm not even going to worry about that until we get to it. So if the root is already there, just give me the positive root. Okay? I know up here. Come on. I said the square root of 16 is plus minus 4. That is true, but that's when you're adding a root in. Okay? So for right now, and I'll be very clear about this on tests or quizzes or whatever. If the root is already there, just give me the positive root. Okay? Let's do all the even ones. Can you do E? No, because it's an even number there, right? So, nope. Let's do this one, a fraction. So what is the 5th root of 1 over 32? So you can look at them separately, okay? You can look at it as, what is the 5th root of 1? I.e., what multiplied by itself 5 times will give you 1? 1, right? 1 is easy, it's always 1. What multiplied by itself 5 times will give you 32? 2, right? If you don't know that, that's okay. We're going to do this enough that you'll start to see there's a pattern here. Let's do F. Forget about the 2 on the outside. Just write that there. And let's look at this. What multiplied by itself 3 times will give you 125? 5. So that is 5. 2 times 5 is 10. All right. Oh, this one? No, it's what multiplied by itself 5 times. So 2 times 2 times 2 times 2 will give you 32. Okay? Look, I know I'm going super fast. I know we're 8 minutes into the course here. It will start to come back to you. Okay? This is just getting your brain thinking. I know some people probably haven't done math since what, first semester last year? All right? And you're doing it last octa of this year. So don't worry too much. This will start to come back to you. Okay, do people have calculators? We'll practice using our calculators for a bit. Now, everybody's going to have a different calculator. You can use your phone if you want to for this, but everybody's going to have a different calculator. All right. I'm going to stop. Sorry, I'm going to stop the video here. Okay, back to page, what page is this? 10, please. So, at the bottom of the page, radicals here. Some terms that I will never ever ask you to define on a test or anything, but you should be aware of. Obviously, this thing is called the radical sign. The number inside is called the radicand, but the most important part of this is this, which is called the index number. Okay? All right? The whole thing's called a radical, but I'm not too worried about that. So the index number is what tells you, are you doing the cube root, fifth root, square root, blah, 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 blah. Okay? So this seems like a weird question, but we'll just do this one anyway. We'll just do B. If there is no number, what is the index number? 2. And the radicand is 50. Okay. All right. Now, I can't even remember if you do this in grade 10 or grade 9. If you are multiplying individual radicals with the same index number, that is the key here. So what's the index number on the 9 and the 4 here? 2. So we're doing square roots. As long as the index number is the same, you can put them both under the same square root. Okay? So this would be equal to root of 36, right? And you can test that by going, what's the square root of 9? 3. What's the square root of 2? Or square root of 4, I just told you. Is 2. What's 3 times 2? Is 6. What's the square root of 36? There you go. So they're the same. Okay? That works for division as well. As long as the index numbers are the same, you can put both numbers under one radical sign or break them up. You can go from here to here. That does not work for addition or subtraction. Okay? So root of 9 is 3, which we've already talked about over here. Square root of 4 is 2. 3 plus 2 is 5, right? But if I put the 9 and the 4 under the square root sign, what's 9 plus 4? 13. Is the square root of 13 5? No. So these are not equal. Okay? So if you are multiplying or dividing, you can take 2 square roots and put them under one radical sign, under one square root sign. You cannot do it for addition or subtraction. Okay? And that's all this is saying, just in math speak. It's just saying the square root or the root of A times the root of B is equal to the root of AB. You can put them together. Okay? Same with division. Square root of A divided by square root of B is the same as the square root of A over B. So, for example, root 3 times root 6 equals root 18. Is that a true statement? Yes, it is, because it's multiplication, right? Because essentially that's saying that, and 6 times 3 is 18. Root 20 over root 10, is that root 2? Yes, because you can put the 20 and 10 under the same square root sign. 20 divided by 10 is 2, so it gives you that. All right? What about the next one? Root 16 plus 9, does that equal root 16 plus root 9? No, can't do it with addition. All right, so now we're going to take 2 and write them together without saying if it's true or false. So root 8 times root 3, that equals root, sorry? I heard 24. Is that what people said? Let's go with that. All right, because that's 8 times 3 is 24. Root 7 times 3 is the same as root 21. What about root 50 divided by root 10? Exactly, because that is the same as root 50 over 10, which is root 5. What about this next one with the square roots inside the square roots? So start on the inside and work your way out. What's the square root of 100? 10. So I've got this. And then you can rewrite that as that. And 10 divided by 2 is? Is that okay for everybody? Sure. Okay, now we're going to take it, we're going to break it apart, because sometimes you want to break it apart. So, what multiplies to 77? 11 and 7. So this is going to be the same as root 11 times root 7. What multiplies to 27? And 9 and 3. So we can write root 3 times root 9. What multiplies to 40? 10 and 4. So this could be root 10 times root 4. What else could you do? You could do 20 and 2. Anything else? 4, 8 and 5. 8 and 5 would work. Any of those are right, okay? So when you're adding or subtracting, can you put them under the same radical sign? No, only when you're multiplying and dividing. I would like you to do 8, 9, and 10, please. And then lesson 2 is done. Congratulations on your first lesson. All right, so we're going to skip the top part because that's just a review of what we just did. And normally this would be done the next day, but in the Octa system, it all just gets munched together into a 2.5-hour period of goodness. So we're going to go right to the bottom here. Okay, who's got calculators? I need somebody to do square root of 80, somebody to do square root, or 2 times the square root of 20, and somebody to do this 4 times the square root of 5. What is it? I know, I just want to know what the actual numbers are, though. 8.94427. Like that?
Yeah.
That's good enough. No, that's good enough. What's 2 root 20? Oh, no, I'm confused. They should all be the same. Is it 8.944? And 4 root 5? I'm assuming all the same, right? Does everybody agree with that? You just gonna take my word for it? That's very trusting of you. So they're the same. Okay. Why are they the same? So this is now where we get into simplifying radicals. So I can take 80 and rewrite it as 4 times 20. Okay? And we just learned the rules that if you have two numbers under a radical sign, you can break it up into two separate radicals. So this can become root 4 times root 20. What's the square root of 4? 2. So that's, so you get 2 times the root of 20. That's where that one comes from. But I can also break up 80 into 16 and 5, which is square root of 16 times the square root of 5. Square root of 16 is 4. And then the root 5 is left over. Okay? So these, where you have numbers on the outside, are called mixed radicals. Mixed radicals. And when you have all the numbers on the inside, like this, it's called an entire radical. Okay? All right. May I flip the page? All right. So this is where my scanning with my phone did not go so well. You have to read stuff at an angle here. So entire, sometimes they're called pure. I have never really heard anybody call them pure radicals, but hey, somebody might. Entire radical just means everything's under the radical sign. A mix just means you have a number out in front. Okay, that is not 1. Oh, hello. What's that? I think it's open. Yeah. So if we have, we're going to convert 108 to a mixed radical. So I want to break up the 108. So they've given us the 3. What times 3 equals 108? 36. If you don't know that, that's fine. Just use the calculator. Exactly. Okay. All right. So then I can rewrite it as square root of 36 times square root of 3. We know the square root of 36 is 6. They even give it to you there. I don't know why they give it to you there. So then you would write it, root 108 is equal to 6 root 3. Okay. So we're gonna simplify these 3 here. 50. Now, I'm going to show you 2 different ways to do these questions. I don't really care which way you use. All right. The first is to figure out a perfect square. Do you know what a perfect square is? It's like the square root of something equals a whole number. So the perfect square of 4 is 2. 4 is a perfect square because it's 2 times 2. You don't get a decimal, okay, essentially. So what multiplies to 50, ideally, that gives you a perfect square? Sorry? Square root of 5? Yes, 25. So I'm just saying, so in other words, I guess what I'm saying is, what number when you square root it gives you a whole number that would multiply to 50? So 25 and 2, okay? Which we can rewrite as root 25 times root 2. What's the square root of 25? Thank you. So it's 5 root 2. Now there's another way to do it if you don't like that way. The other way is, I'll write it over here. And I don't care which way you do it. This is the factor tree, which you might have seen in grade 10. So you go, what multiplies to 50? It doesn't matter. You can break it up any way you want when you do the factor tree. So I can just go 10 and 5. All right. And then you go, what multiplies to 10? 5 and 2, or 2 and 5. Okay. You go until you can't break them up anymore. Okay. And then, what's the index number out here? 2. That is telling you you need pairs, you need 2 numbers. All right. Which I have right there. So you can pull that out, which gives you your 5. What's left on the inside? What have I not pulled out? Not 10. You go to the bottom row, sorry. Just the 2 is left inside. Okay? Yeah, no, you can't. That would be like, so 2 root 5 is a totally different number. Yeah. All right. 45. What multiplies to 45? A number that has a nice square root. 5 and 7. 5 and 9. Yeah. So I could write it like that. Square root of 9 is 3, so it's 3 root 5. If you want to do it the factor tree method, you can go 9 and 5. 9 is 3 and 3. I'm looking for groups of 2 because the index number is 2. So that goes onto the outside, and I'm left with a 5 on the inside. I don't care how you do it, okay? If the factor tree is better for you because you saw that in grade 10, do that. If this breaking it up into perfect squares is better for you, do that. All I care about is that you get the right answer, okay? What multiplies to 320? 32 and 10. So I'm going to do the factor tree, and then I'll do the other one. See if you can get the answer using the factor tree. Break it up until you can't break it up anymore, i.e. go to prime numbers. Keep it there. Okay. People done this one yet? Okay, so you can see, that's the thing. When you do a factor tree and the numbers get big, it's more work, essentially. Okay? Now, there's a couple tricks to this. So you could just keep breaking up this to 2s, right? And I'm looking for groups of 2, correct? Because my index number is 2. So there's a group of 2, there's a group of 2, and there's a group of 2. So how many 2s come out? Not 6, 3. Because a group of 2, when you pull it outside of the radical sign, becomes one number. Oh, okay. So I see what you're saying. So when you write them outside, you're going to get 2 times 2 times 2. What's left inside? What have I not circled? The 5 right there. 2 times 2 times 2 is 8. So that's the factor tree method. If you don't want to do the factor tree method, and you want to use a perfect square, 64 and 5 give you 320. What's the square root of 64? 8. So it's much faster to do it that way. The thing about this method is you have to know the perfect squares, okay? And they actually list them right here. Okay, up to 15 in your book. You will have a calculator on your test, so you don't need to worry about if you can't do this in your head, that's fine. Okay? May I flip the page? All right. Now, we're going to convert these radicals. They are mixed radicals. We're going to convert them to, I'm going to say more mixed radicals. What they want you to do is ignore that number there and break up the number that's inside. Okay? So this 2, just kind of write them off to the side. And then just deal with 192. What multiplies to 192? Sorry? 64 and 3? Yeah? Okay. So that becomes, I'll write it right here, 64 times root 3. What's the square root of 64? 8, right? So it's 8. The root 3 you can't do anything with. Don't forget about this 2. So it's 2 times 8, which is 16 root 3. Okay? If you did it with the factor tree method, I'll just show it, okay? Because it's more work, but that's okay. If I did it with a factor tree method, I'll go up. 192 is 4 and 48. 48 would be 4 and 12. That would be 4 and 3. Now, this is a trick if you're doing the factor tree method. I'm looking for groups of 2, right? Does everybody agree with that? As soon as you get a group of 2, even if it's not the lowest number, you can pull that out. Right? Or you can break those all the way down to 2s. So I know 4 is going to come out. That's going to be 2 and 2. So one of those comes out. And I'm left with the 3 on the inside. So 4 times 2 is 8. And then 8 times the 2 that was out there. So you get the same answer. Okay? Again, I don't care how you do it. Just know how to do it. All right. The 3/4. Everybody freaks out when they see fractions. Don't worry about the 3/4 right now. We just write them off to the side. Deal with the 160. What is a nice number that multiplies to 160? Yeah, 16 and 10. What's square root of 16? 4. And the root 10 you can't do anything with. So now I have 3/4 times 4. Now you can do it on a calculator if you really want to. But does anybody remember how to multiply fractions? If I had, yes, because if you're multiplying, I'll just write it. That's like 4/1, right? If you're multiplying fractions, it's top times top, bottom times bottom. What's 3 times 4? 4 times 1, 4. What's 12 divided by 4? 3. What you could have done right at the beginning is these 2 4s, because one's up top, one's underneath, will cancel each other out. And you just get 3 root 10. Okay? All right, C. Can you square root 7 and get a whole number? No. Can you square root 9 and get a whole number? Yes. So we know through what we learned 20 minutes ago, I can rewrite this as this. Is that true? Okay, 7, I can't do anything, so that just stays as root 7. What's square root of 9? That's all you can do with that one. Now, you can write it multiple different ways. That is correct. Sometimes they'll write it like this as well. Those mean the same thing. Okay. It's break time. When we get back from break, I'll give you a few questions. So, we have index numbers of 3 and 5 here. So we'll do it with the perfect, now we're not looking for perfect squares, we're gonna look for perfect cubes, okay? And they're actually listed right there on the side. See if I can keep them both on the same screen. So, at the bottom here, 6,000. How do you want to break up 6,000? What times what is 6,000? Oh. So what multiplies 6,000? Anything. 6 and 1,000. Perfect. So I can rewrite this as 6 times 1,000. These should have cube roots out there. So, what number multiplied together 3 times will give you 1,000? 10. All right. So this becomes 10. And the cube root of 6 you can't do anything with. So it's like 10 times the cube root of 6. Okay? Now, if you are the factor tree person, you're looking for groups of what? 3. The index number tells you. So you could do 6 and 1,000 again. 1,000 is 10 times 100, and 100 is 10 and 10. Now, like I said before, as soon as you get to a group of 3, you can just pull that out. Okay? So this little bit comes out, and you get 10. You're left with the cube root of 6 inside. So you get the same thing. Okay? And you always want to go until you have the smallest number possible in here. All right? You can't break that up. That'd be only 3 and 2, but those don't break up anymore. Okay? Because there's no number, well, there is a number, but the cube root of 6 is like a decimal number. I only want whole numbers. Okay? So you go to the smallest whole number you can have in there. All right. 320. What multiplies to 320? And yeah, what multiplies to 320? What's a simple breakup? 32 and 10. 32 and 10 would be a perfect one. And we're looking at the fifth roots of this, right? We talked about the fifth root. What number multiplied by itself 5 times will give you 32? Okay. So this can become 2 times the fifth root of 10. There's no whole number that multiplied by itself 5 times will give you 10. If you are doing the factor tree method, you can do the same thing, 32 and 10, 8 and 4, 4 and 2, 2, 2, 5, 2. I'm looking for groups of what? And 5, right? 1, 2, 3, 1, 2, 3, 4, 5. There's 5 2s right there, right? So that would come outside, and you're left with a 5 times 2 or a 10 on the inside. So you get the exact same thing, okay? C. First of all, can you do C? Yes, because it's an odd exponent, right? Or an odd index number. Okay, what multiplies to 16? 8 and 2 would be the good one. Does it matter what you put the negative on? You just put it on 1, either the 8 or the 16. or the 2, sorry. You can put it on the 2 if you wanted, but I'll just put it on the 8. And this is cube root. What's the cube root of 8? I.e., what number multiplied together 3 times gives you 8? 2. And it's negative 2. Cube root of 2. Is that okay? Kinda. It's just going to be a little practice. 6 and 7, please. And there's one last thing I want to do at the end, but we'll wait. So this is technically not in Math 11, so this would be a bonus type question on a test. Okay, but you should, I think it should be in Math 11, so I'm teaching it to you. But it will be a bonus type question, it won't be part of an actual test, okay? Page 18. All right, so we're dealing with variables now, okay? So if I have, I'm just gonna write it over here. If we have x to the 6, what is my index number here? 2, right? If no number's written, it's 2. So if you think about x to the 6, that is the same as x times x times x times x. 6, there's 6. Okay. I have an index number of 2, which means I'm looking for groups of 2, right? There's a group of 2, there's a group of 2, there's a group of 2. So this one comes outside and I get x. This one gives me an x. That one gives me an x. What's x times x times x? X cubed, right? Because you add the exponents. So you get x cubed. Okay, here's my question. How can I go from this to that without writing all that stuff? What does 2 represent? The square root, right? It represents the index number. So whatever the exponent is inside here, if you divide by the index number, you get this. Okay, so for example, the square root of x to the 4. What's my index number? What's 4 divided by 2? No. If the number is not written, it's always 2. Everything else will have a number written. What is the square root of y to the 10? y5. Square root a to the 8, b to the 6.
A, B, 7. A4, B3.
You don't add them together, just be the individual. So a4, b3. Cube root of x to the 24. 8, right? 24 divided by 3 is 8. Cube root of y to the 6. So y squared. Okay, that works out nicely if this is divisible perfectly, right? What if it's not? So x to the 5th, you rewrite it into something that is, okay? So x to the 5th is the same as x to the 4 times x to the power of, that's a 1 there, right? If you don't have a number, it's a 1. This you can break up into that. We learned that today. What is this? What's the square root of x to the 4? 2. X squared, right? You can't do anything with this. So your answer is just x squared root x. So if it's not perfectly divisible by your index number, rewrite it into something that is. All right, here's the last 4 questions for today. A7, what's my index number here? 2. Is 7 divided by 2?
No.
No, so how do I rewrite a to the power of 7 so that something is divisible by 2? There you go. It's a6. I'll even write the 1. You don't have to write the 1 though. What's a6 become? a3 with no radical sign. An a, or sorry, with an a inside. Is 9, what's my index number for the next one? B. It's 2, right? Is 9 divided by 2? Divisible by 2? Not into whole numbers anyway. So I rewrite it as what? Yeah. Square root of t8, square root of t. What is the square root of t to the 8th? 4. So it's t4 root t. Okay. Next one. Is 5 divisible by 3? No. How do I rewrite the 5 into something that is divisible by 3? 2 and 3, right? I can rewrite this as x to the 3, x to the 2, and it's the cube roots, right? Does everybody see that? I don't want to write this as x to the 4, x to the 1, because 4 is not divisible by 3. Correct? So what's 3 divided by 3? So it's just x to the 1, or just x, cube root x2. Okay? What about this one? What do I rewrite it as? You can do 3 and 4. Go to the high, like, that's what I want. 6 and 1. That's, you want to do that. Six divided by 3 is 2, so it's that. Does that make sense? All right. Can you do those? I know. Thanks for noticing. I can tell. All right. What if you have 2? What's my index number for the first one? 2. So which one do I have to rewrite? The y, right? So the x6, what does that become? We can just do that one. 3, so I get x cubed. The y I'm going to rewrite is y4, y1 to give me what's left inside? Now we got numbers and letters. So the numbers do the way we've been doing. Square root of 18. What can I rewrite 18 as? 9 and 2, right? I can rewrite it as root 9, root 2. X cubed. 3 is not divisible by 2, but what is? 2. So I can rewrite the x as correct. Is everybody with me? Okay. What's the square root of 9? 3. What's the square root of x squared? That's just x, right? What's left inside the square roots? This one's gone, that one's gone. A 2 and an x. Let's do the last one. Let's do D. Okay, last one for today. So, cube root. What multiplies to 40 that has a nice cube root? Everybody wants to say 20 and 2 or 10 and 4. Neither of those have cube roots. What multiplies to 40 that's a cube root? 8, right? So I can rewrite the 40 as the 8 and 5. Is x4, how am I going to rewrite that? Hmm? 3 and 1. Okay, what about the y? Do I need to rewrite the y? No, I'll write it out just because I've been writing everything out. Okay, now we just do each one. What's the cube root of 8? 2. Gone. No, but 2 times 2 is 4, 4 times 2 is 8. 2 to the power of 3 is 8. x3 cube rooted, what does that become? X, not just 1, say x to the 1 or something. Y to the 9 cube rooted? That's right. Y3. What's left? 5 and an x. And that's your answer. If you want some practice with those, it's 10 and 11. Please make sure you finish all the questions that we did today if you didn't finish them. I will post the videos